Welcome back. Today we're going to be covering section 7.6, which is the integration using tables in computer algebra system. So what happens? There are times that we've gone through every type of integration method, but sometimes there's problems that just don't fit that. And what we found that over time, mathematicians have noticed these patterns and said, if I can get this problem into this form, then excuse me for a second. If I can get this problem into that form, then I can. It seems to always integrate this way. So they put together this list of integrations, and they're actually your book has a small number of them, but there's actually books that have all these integrations in it. So on Blackboard, you'll see a form, and this one's only 5 pages long, and it's a list of all the possible integrations that we're going to need for the book. And some of these you already know, like e to the u du is always e to the u plus a constant. The sine of u du is equal to minus cosine u plus a constant. So then there's other things that I don't necessarily know, and I'm saying, all right, I'm in this form, so this is how I would get the answer. On the test, I'm going to provide this for you, uh, so you don't have to worry about that. You'll need it only for this one particular test, and we won't be using the integral tables anymore. So let's get started. The next problem, or the first problem, the first problem is 2 over x plus 3x plus 1. And typically we say, well, we're going to let u equal x. So I'm going to open up my integration table, and I'm going to start looking through that. So I'm looking through, it's none of the first ones. And the nice thing is this is giving me a hint. These are all square root of a squared plus u squared. Well, I'm not in that form. It's also telling you that a is greater than 0, so they're not negative numbers. All right. And here again, I'm going through this since it's a squared, but I don't have a square root. The problem, I'm going to go through here, and here are some different ones. And our problem is 2 over, say, a u plus. So what we could say is I could look at it as 2 over a u. Hold on for a second. As I was saying, there's a 2. I'm going to put it out front because it's a constant. Instead of dx, I'm going to put a du because I'm going to say u is equal to x. And then I have something times an x, which is a constant. Whoops. Something times an x, which is a constant. And then I have adding a constant. So I'm in this form, and that's what I'm looking for on my sheet. So I'm looking through here, 47, 48, it's close, right? But I also need a u on the outside. And then I look at 49, and it's exactly what I'm looking for, right? It's a du. There's a u times some quantity. And this is how I'm going to integrate it. That's the answer. So we're saying on your test, this is how I want you to do it. You're using number 49, and that's in the form of du over u times a plus bu. And when I integrate that, it should integrate 1 over a times the natural log of the absolute value of u over a plus bu, close the absolute value, plus c. So this is saying you know which one you're using. This is the formula. This is the result. Then you should be going to tell me u is equal to x, a is equal to 1, and b is equal to 3. That's really for you to make sure you don't mess up. You're going to rewrite your problem to be 2 dx over x times 3x plus 1. So it looks exactly like what we want. Now it's 2 times the whole thing, right? Because it's 2 times whatever I'm integrating. 1 over a, which is 1, the natural log, u, which was x, all over a, 1, plus b, which was 3x, plus c. So finally, it's just 1 over 1 is 1, so I have 2 natural log of x over 1 plus 3x plus a constant. That's the result of the integration. Again, all we're doing is looking for patterns. So again, I'm going to say, what happens if I let u equal x. Then I'm in the form of a u du over the square root of u minus a constant, a. It could be b, I don't know what it is, right? And then I could also say that there's a constant in front of u. The constant's 1. So again, I'm going to go into my integral tables, and I'm going to look for something like that. It's probably going to be in the section, so I'm going to slowly look through here and see what I find. And lo and behold, number 55, it's a u over d, u times du, all over square root of a plus bu is equal to. And this is what I'm going to, this is the result. So here I go. Now that was plus. Well, I could say, going back to this problem, it doesn't say that b has to be positive or negative. So I'm allowed to use this. So I could rewrite this as a u du, right? And it doesn't say about a, so u, a, I'm sorry, a plus bu. Because a could just be a negative 1. So we're in the form of u du, a plus bu, square root. And that's going to result, and by the way, this is number 55. Again, you should tell me which one it is. That's going to be 2/3 b squared times the quantity bu minus 2a, a plus bu, square root of a plus bu, plus a constant. Just to double check, 55, 2 over 3b squared times bu minus 2a, square root of a plus bu plus c, and we're in the form of a plus bu. So in that form, I have all the parts I need, so I'm going to fill it out. So I have x over negative 1 plus x dx. So I get 2 over 3 times negative 1 squared times x minus 2 times a negative 1 square root of negative 1 plus 1 times x plus c. I can clean this all up now. 2/3 x plus 2 square root of x minus 1 plus a constant. And again, all we're doing is plugging and playing. We're seeing, we're looking for what we have. It's all about pattern matching. So we're looking at that. Now this one's not very straightforward, but here's a trick. I could say, let u equal not x, but x squared. Because none of the formulas are x to the fourth. Then I get du is equal to 2x dx, or 1/2 du is equal to x dx. So there I have the things I need now to substitute. So I have a 1/2. It looks like I have a u squared minus 2 squared du. So I need to find something like that, where we already know that u is equal to x squared, but now a is equal to 2. So we're looking for something to be a u squared minus an a squared du. Going back into our formula sheets here, all right, we're looking for something with the square roots. Here is u squared minus a squared, where a is greater than 1, a is greater than 0. And look, the first one, number 39. I have a u over 2. Yep, this looks good. So we're saying number 39 is the one we want to use. So I'm going to write that down. Number 39 is the form of the square root of u squared minus a squared du. And that results into u over 2 times the square root of u squared minus a squared minus a squared over 2, the natural log of u plus u squared plus, oh, not plus, can't read my own handwriting sometimes, minus a squared plus a constant. So again, we now know what u is and we know what a is. So we're going to fill this out. U was one, sorry, I have my 1/2 out front. And then I have to multiply. U is x squared, so I have x squared over 2. U squared, well, x squared squared is x to the 4th, right? Because u was x squared, and I need u squared, so it's x to the 4th. Minus a squared, well, a was 4, so when I square it, a was 2, when I square it, it's 4. Minus 2 squared, which is 4 over 2, the natural log. U again is x squared plus u squared, that give me x to the 4th, minus 4 plus c. I can clean all this up, distributing the 1/2, x squared to the 4th, x to the 4th minus 4, minus, well, 4 over 2 is 2, and I have a half, so 1, which is the natural log of x squared plus the square root of x to the 4th minus 4 plus a constant. Let me clean this up so you can read what I wrote. X to the 4th minus 4. And that's my answer. All right. And again, all we're doing is looking to see. But some of these aren't very straightforward. Like we had to look at this problem. I don't have anything in my tables that are x to the 4th, but I could make it work because I could say u is equal to x squared. And I can rewrite this, right? Again, because we know that I can rewrite x squared squared minus 2 squared. That's all we did. Don't forget my dx. So let's move on to the next problem. Now we have cosine x sine squared x minus 9. Again, we got to come up with a trick. And then we fall back to what we learned earlier in this chapter. I said, well, what happens if I let u equal sine of x? Well, then du is equal to cosine of x dx. So there's my cosine of x dx. So I have du over u squared minus 9, which is 3 squared. So u is equal to x. I mean, u is, sorry, not equal, u is equal to sine x. A in this instance is equal to 3. So I'm going to go through my problems here again. Again, you should hopefully have your sheet that you can look through and try to find these on your own. I know I'm going through here. I already know which ones I'm looking for, but you should try to find these on your own and make sure you're comfortable with this list. So I'm looking for something over u squared. I'm looking at this section, and if I look at 20, I have a du over u squared minus a squared. So it looks like I can use 20. I'm going to go back here. I'm going to tell you which one I'm using. Number 20. And that's du over u squared minus a squared. And that's equal to 1 over 2 times a, the natural log, u minus a all over u plus a, close that, plus c. We know what u is, we know what a is. So now we're looking at 1 over 2 times 3, the natural log, sine of x minus 3, sine of x plus 3, plus a constant. So this final answer is 1 over 6, the natural log of the absolute value of sine x minus 3 over the sine of x plus 3. And don't forget to add our constant, because these are indefinite intervals. Now we got to try to be tricky about this. What can we do? Well, let's try this. Let x, I'm sorry, not x, but u equal e to the x. Well, then du is equal to e to the x dx, which is good again because here's the e to the x. So I'm looking at a du over 3 minus, well, e to the 2x is equal to e to the x squared. So I got u squared. And 3 can be rewritten, right? 3 can be rewritten as the square root of 3 squared minus u squared. So we can say a is equal to the square root of 3, and u is equal to e to the x. So we're looking for something that has the form of a du over an a squared minus a u squared. Well, that one just happens to be 19. Right? We were just looking at 20, but now look at 19. 20 was u squared minus a squared. 19 is a squared minus u squared. And then the only difference is in the absolute value. They're switched. So this is equal to number 19. 1 over 2 times a, the natural log of the absolute value of u plus a over u minus a plus a constant. And now, like I said, we already listed what everything is. 1 over 2 square root of 3. We're not going to rationalize that. We talked about that in class. The natural log of square root of 3. Oops. I'll put them in the right order. E to the x plus the square root of 3 over e to the x minus the square root of 3 plus a constant. And again, that's my answer. We're not going to worry about rationalizing. Square root of 3 is fine. All right, we only have a few left of these. So give me a second. I got to... Okay. So we're going back to these problems. I have an e to the x, e to the 2x minus 1. And I could rewrite that as e to the x squared minus 1. That's 1 squared if I really want, dx. So I can say let u equal e to the x. And then and then if I do that, if I think about that, I can rewrite this. I could say, well, the natural log, or take the natural log of both sides if I wanted, of the absolute value of u is equal to x. And if I take the derivative of both sides, because I can't take the derivative of this, I mean, I can, but it's not going to help me. If I take the derivative of this, I get 1 over u, right? du is equal to dx. So now I have a substitution here for my dx. So now I have a 1 over u du, and then I have a u squared minus 1. So I'm going to go back here and look through my list of things and see if I can find something that would qualify for that. So I'm going to go through here slowly. This is a u squared plus. These are all pluses. I don't want that. I want a minus. They're also telling me that a has to be greater than 1. So I can't say, oh, I'll go minus a minus 1 because a has to be greater than 0. Not I said 1, but a has to be greater than 0. And I'm a minus 1. So that doesn't help me. And here I go. Look, an a squared minus u squared. This might have some potential in here. So we're going to go through here looking, but I need a 1 over u. This is a squared minus u squared. I want u squared minus a squared. Nothing here. I'm still in that form. A is greater than 1. It's telling me a is greater than 0, so I'm okay. Because this is a subtraction. I'm okay with this. Look at this. U squared minus a squared. Well, 1 squared, that'll work. And I added 1 over u. U's in the denominator. So this looks like what I'm looking for 41. 41 looks like what I want. So I'm going to go back to my problem. I think it's 41. I'm going to say number 41, which gives me a square root of u squared minus a squared all over u du. And that integrates to square root of u squared minus a squared minus a arc cosine of a over the absolute value of u plus c. So let's go back and just double check that I wrote that correctly. 41 u squared, square root of u squared minus a squared minus a times arc cosine of A over the absolute value of U plus C. Yep, that's what I wrote. So now we're going to go back and we know what we have and we can do all our substitutions. We know what U is. We know what A is. So U is e to the x. So e to the x squared, where that's e to the 2x, minus 1 squared is just 1. Minus A. Oh, A was just 1. Arc cosine 1 over the absolute value of e to the x. But e to the x is always greater than 0, so I don't really need the absolute value sign. Plus a constant. I'm going to get rid of that 1 there. So my final is e to the 2x, subtract 1, minus arc cosine. Instead of e to the x, I can just e to the minus x. Right? Because 1 over e to the x, 1 over e to the x is equal to e to the minus x. So that's what I'm going to do. And since e to the x looks like this, it's a function that has a horizontal asymptote that's 0, it's never less than 0, so I don't need the absolute value for that either. Why don't you guys try this one on your own? It's a trick similar to what we did a couple pages back, where you had the x to the 4th, I think it was. So try this one. I'm going to work on it myself and come back and show you what I have. Okay, hopefully you've had enough time to look at this and get your answer. So we're going to let u equal x to the 5th. That's what I wrote here. And then du would be 5x to the 4th dx, or 1/5 du is equal to x to the 4th dx. So I can substitute what I see in yellow with this. Just a quick note, x to the 10th is the same thing as x to the 5th squared, just to remind us. So I can't get rid of that 1/5. I need to still have it, otherwise I've changed my problem. So here's my 1/5 out front. I rewrote it as a du now because I did a u substitution. Instead of writing 2, I can write that as the square root of 2 being squared. That allows me to find in my list number 43. 43 is a du over the square root of u squared minus a squared. That will integrate to the natural log of the absolute value of u plus the square root of u squared minus a squared plus the constant. So then by substitution, this is what I have. Let's move on to the next slide. So now this time they're telling us to use a computer algebra system. There's a lot of them out there. The one I would want you to use is either Wolfram Alpha, Mathematica when we get to that point. So here we go. I want to integrate, and these are very similar to the way you would do this in Mathematica. You could also do this on your calculator. Integrate. I want to integrate x times x squared plus 2x plus 4. Close this, raise that to the half. You could put a half or you could put 0.5. And I'm doing this all in terms of x. Hit enter. And it's working. It's going to take a while sometimes. So give it a moment, let it go through what it needs to process this. So give it a second. I'm going to pause this so you don't have to watch it. Oh, there it is. So this is the answer it gave me. I'm going to go back to my slides. I'm going to open this copy tool. Where'd it go? Where's the camera? I do not see the camera, so hold on for a second. So I'm going to use my screen capture tool here so I can capture the answer from here. And this is all I did. I'm going to copy the whole thing. Matter of fact, here's the function. Hopefully it didn't copy that line. If it did, I apologize. And it did, so let me try this one more time. Complete. Go back to where I was. We'll copy this one more time. And instead I got a different line. All right. It's also got a bunch of alternate answers. These are just different forms of the same answer. So here we go. And that's just going to be posted on your this. Okay, well that's the end of this video. I showed you how to get the answer. You can do this in Wolfram Alpha. When we get to Mathematica, you can do this in Mathematica, or you can even do this on your calculator. I hope you got a chance to try some of these on your own, and thank you very much for your time. Look forward to seeing you in the next class.